Biddy-doo, biddy-doo. Oh, hello there. Just another Thursday. Not like there's anything going on in the past few recent weeks. What's this? Sees carbon-rich dust screens in the first billion years of cosmic time. I might have a few scientists scratching their heads. Well, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one rule ad. I don't think it rules them all, and it might be just hyper-rural turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rural turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, what's going on? Well, like many things, I heard about this first from Anton Petrov. We go to our friend Anton. The link's in the doobly-doo to his the stuff and things here. But I think this is a good video, and you'll learn a lot of interesting things. He actually also does put links in the doobly-doo. Not everyone does. I'm just saying.
Places for many different planets and stars, and it seems to be responsible for the evolution of various galaxies. Ironically, in astronomy, it's also a bit of an issue. It absorbs a lot of wavelengths, and so it actually makes things a little bit difficult to observe. If, for example, you're trying to look at these complex organic molecules, these cyclical molecules,
apparently within, I don't know, the first 700,000 years of the universe as we know it according to the current cosmological standard, most of the more previous surveys, we see carbon dust within about a shift of redshift of about 3 or so, basically within our more local universe. Why? Because the whole concept behind it, again, I'm not a professionally trained physicist, cosmologist, astronomer, any of those things. I'll do it on the internet. But to my knowledge is, all right, you start off, you get mostly your hydrogen, your heliums and stuff like that. You have them gravitationally coalesce into stars. And as that happens, they gain density and mass and pressure, and they start to generate new elements, and then they go kaboom. And then you'll have like neutron stars and stuff, and then those explode and the elements get all around. It's like, all right, you start off with some very basic building blocks, and eventually you get something more complex. Carbon is only element number 6. But generally it was thought, probably not going to see a huge amount of carbon dust and everything going on within the early universe as we know it here. Yeah, things are about to get weird. Why do I say this? Okay. Let's not bury the lead. So this is from ESA. I believe that's the European Space Agency. It's a website. This is from about a month ago. So for the first time, NASA ESA CSA James Webb Space Telescope has observed the chemical signature of carbon-rich dust grains at redshifts approximately 7. I think it's like 6.71 approximately, which is roughly equivalent to 1 billion years after the birth of the universe. Similar observational signatures have been observed in the much more recent universe, attributed to complex carbon-based molecules known as polycyclic aromatic hydrocarbons, PAHs. That's a lot to say. It's PA. Good old PA. It's the reason we're here, I believe. It's not thought likely, however, that PAs would have developed within the first billion years of cosmic time. Therefore, this observation suggests the exciting possibility that Webb may have observed a different species of carbon-based molecule, possibly minuscule graphite or diamond-like grains produced by the earliest stars of supernova. This observation suggests exciting avenues of investigation in both the production of cosmic dust and the earliest stellar populations in our universe. It was made possible by Webb's unprecedented sensitivity. I was waiting for this to say, made possible by viewers like you. To be fair, it's paid for by tax revenue. I believe that is an accurate statement, possibly. But it's very interesting. We're going to go back in time for just a moment. One, I credit this just because I was using most of the image. But this is from spectron.ieee.org. I have no idea what that is. Dust in space. But essentially the whole gist of what's going on here is, well, if we got dust, And if things are affected by forces of gravity and electromagnetism, and electromagnetism is like about 137. It's a lot stronger than gravity as we know it. But we usually only account for gravity. Why? Because magnetic fields, electromagnetic. We don't know. So we sometimes. I'm just saying, my personal opinion. I feel like the force of electromagnetism has a wee bit more influence on cosmogenesis than we may be incorporating into our current models. Just a gut feeling. And I remember Professor Keating had someone I was like, yeah, we don't know. It's like, I appreciate it. If we don't know, we don't know. That's fine. That's totally cool. But hey, Lauren. Hey, thank you for joining. Good to see you, my friend. But basically what we got going on here is, yeah, they're developing ways, and this is back from 2019, to try to measure that. So that's totally cool. Carbon. Well, what is carbon? It's a chemical element with the symbol C and the atomic number 6. It's a non-metallic tetravalent. Oh, so it sounds like it's made up of find the capacity. Oh, okay, so it forms in threes and stuff. Well, that's groovy. Hey, Callie. But just going through a little bit of carbon stuff here, and again, they have the prediction maps, the spectroscopic cycles, crystal structure. It's a hexagonal lattice. Seems to be a pretty cool thing. That's also all we get dodecahedrons. Are those buckyballs, or I think they might have the pentagons in there too? I know there's buckyballs somewhere in the article, or which apparently you just get when you're like from like soot and stuff like that. Apparently, we didn't look at. I think Professor Wolfram was the first person that told me this. It's like, oh yeah. We're these complex structures that Buckminster Fultz was talking about, and then more recently it's like, yeah, it's in like chimney soot. What? I guess we never looked. According to my recollection, carbon, according to Wolfram Alpha, there, you get your basic things: the atomic mass, because it's got 12 nucleons, protons, neutrons, and a little bit of extra stuff there. The AMU, we have a previous video on the channel. If you're curious about what may be going on there, we got all the abundances and all that cool stuff. But I know, Kali, they're talking about maybe there's an exciting new form of carbonite, graphene. Maybe that could totally be true. Or hear me out. Hypothetically, if T was a little greater than 14, perhaps if the observations we have, if the universe is ginormous and it's been going on for a while, and we keep most of our other things in place and don't need to invent anything new, if we assume that whole general homogeneous and isotropic, was it the cosmological principle or whatever? I don't know. I think that may explain a little bit. Maybe could be totally wrong here, but so we have that. Let's go over with this article. I opted to give nature money. I'm like, wait. If I pay you the $200, you're gonna give me all the access to the articles, and you're gonna send it to me. I think that just buy the article for online access was like $30. I'm like, I don't even really care. I just want access to it. If I can have access to all the I want to read further, but we're only going to go through just a quick thing here because this was another thing that was in Anton's video. Carbonaceous dust grains seen in first billion years of cosmic time, and they go into the technical specifics there. I'll just read this, and I'll read one, like 2 sentences from the article because I don't want to get in too much trouble. And Professor Keating read similar stuff and things, but. Large dust reservoirs up to 10 to the 8th solar masses. Oh, it's like 10 billion masses worth of the sun. That's a lot. Have been detected in galaxies up to redshift Zeta 8. Oh, where the age of the reservoir universe was only about 600 million years. Generating significant amounts of dust within such a short timescale has proven challenging for theories of dust formation. It has prompted the revision of the modeling of potential sites of dust production, such as the atmospheres of asymptotic giant branch stars in lower metallistic environments, supernovae, ejecta, and the accelerated growth of grains in the interstellar medium. However, degeneracies between different evolutionary pathways remain when the total dust mass of galaxies is the only available observable. Here we report the observations of 2175, a dust attenuation feature, as well as the Milky Way and galaxies at Z of less than or greater than 3 to the raise to 9. What? Oh, those are the section. Okay, that's I thought all of a sudden they were putting it to the exponents. I'm like, why are they raising the Z shit to the exponents? Why are you doing this to us? In the near infrared spectrum of galaxies up to Z of 7, corresponds to the first billion years of cosmic time. Blah blah blah. Okay, so they're suggesting most likely in Wolf-Rayet stars and everything. Was it? I believe Event Horizon actually had just came out with something suggesting they may have discovered more of these things. Again, totally cool. I'm biased. We all got our biases. It's fine. Just a minute. But the interesting thing that I found, yes, a carbon a long time ago. Hold on. Da-da-da. This is educational. This is educational. Okay. Beyond the local universe, the feature has previously only been observed spectroscopically in massive metal-enriched galaxies at Z less than or equal to 3. So basically, kind of more around us and everything. We see a bunch of carbon. I believe Professor Keating is familiar with the observational feature of dust. But yes, Ark. It is very interesting how a lot of things we thought may or may not be true. And again, we're learning things. We have when you stick William Blake comes to mind. It's the whole to see the world in a grain of sand and heaven in a wild flower. Hold infinity in the palm of your hand and eternity in an hour. Yeah. We're basically specks of dust on this ginormous blue marble hurtling throughout the cosmos within our little spinny Rasen shuriken type galaxy out there, hurtling through just however far. I'm of the opinion it's about 10 to the 32 meters in magnitude. Again, bias there. Observable universe is 10 to the 26 meters. Everything we see, as far as we know it, that's it's less than a quadrillion light years. That's what I know. I just sorry, different scale. Yeah, even with humility, it's. I mean, I'm making big claims and everything here, but well, not really here, but just going over what I think is quite interesting. But yeah, that's the whole process of science. Science. Do we know what is true? No. But we're trying to be a lot less wrong. That's my claim, at least. So that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world up there, but it's hoping for a better tomorrow.